Welcome everyone. This is an instructional video on how to deploy Citrix Netscaler in AWS to support Citrix XenDesktop. So we're basically deploying it in ICA proxy mode. The reason I made this video is because there was a dearth of exact steps of how to do this with today's version of Netscaler as well as today's AWS Council. This is just one way to do it. I'm sure there are many other ways, but hopefully you will find the guidelines here useful. We will use the latest available Netscaler build in the AWS marketplace and the current GUI interface for accessing and managing AWS or Amazon Web Services. We will also explore how to accomplish Netscaler HA in AWS and describe other mechanisms for accomplishing high availability. We are assuming that our viewers have some working knowledge of how to deliver XenDesktop using Netscaler, that's not a new concept. And we're also assuming that you guys have some familiarity with AWS cloud services, particularly those focusing on using AWS as an infrastructure as a service. So let's look at a couple of assumptions in this demonstration. So we're assuming the following assumptions regarding the environment that we are using in this video. First of all, we're using an in-house Active Directory service for authentication. So we're not using AD in the cloud. It's our own AD servers. There is an AWS direct connect between the on-premise data center and AWS. So kind of like an MPLS or VPN connection between the two sites. The on-premise firewalls allow authentication communication between the on-premise Active Directory servers and the target EC2 instances in the subnets that are hosted in AWS. So there has to be communication, authentication communication that is allowed between instances in AWS and the on-premise data center that we are using for Active Directory. All other Citrix infrastructure components are hosted in AWS, although from the perspective of the Netscaler, it doesn't care where those components are hosted as long as it can talk to them. So if you have Citrix components hosted on your on-premise data center, that will also work. But in this demonstration, we're assuming that all the Citrix infrastructure components, including the Netscaler, is in AWS. We are only demonstrating how to configure the Netscaler itself in AWS to the point of being able to launch a published desktop. We're not exploring the mechanisms or rules needed to that have to exist to ensure that the desktop can communicate with other network resources, such as cloud-hosted applications, your on-premise applications, things like that. So we're only looking at the XenDesktop stack and its functionality. We're not looking at once you're logging onto the desktop, how does a user get everywhere else? That's a firewall rule exercise and a routing exercise, and we're not going to cover that here. We will also not be demonstrating connecting to the Netscaler Gateway virtual server directly from the internet. You can publish the gateway to the internet directly through AWS services, but right now we're going to assume that users are coming from our on-premise data center into the Netscaler in the cloud and then launching an app that way. It doesn't really matter whether you're coming from the internet or coming from internally, and the Netscaler functions exactly the same way. But for the purposes of simplicity, we're going to demonstrate it as if we were coming from the on-premise data center. So let's look at a couple of prerequisites. Obviously, you need an AWS account. If you don't have one, then you're not going to be able to make use of the exercises in this video. You must have created a VPC. It doesn't have to be the default VPC, but it must exist and it must have subnets defined. Again, and for purposes of this video, we're not going to go through step by step of how to create an AWS account and how to create a VPC and subnets. Those are something that is pretty straightforward, actually, if you go through some introductory courses with AWS. But we're going to assume that those already exist. You should define at least 3 subnets for this video. For this exercise, but in this video, we're working with 3 subnets for the Netscaler and 1 or 2 for the VDI instances. So it's important to have at least 3, or else you're not going to be able to demonstrate everything we are going to show in this video with regards to Netscaler and AWS. We're also assuming that there is a direct connect, as stated before, between the AWS environment and the on-premise network. If all components are hosted in AWS, however, if you're doing this as a lab or a proof of concept and you have Active Directory in AWS, then there's no need to have a circuit or VPN connections. Everything can just be in the cloud. But in this case, we're kind of putting or demonstrating a hybrid scenario. You will also need at least the following permissions on your AWS account. If your AWS account was provisioned to you, you'll want to request these permissions. If you opened it up yourself, you're signed up on your own, then you'll automatically have these permissions. You need to be able to create an AWS IAM role. This will be used to enable Netscaler HA, and we'll go over steps on how to do that. You need to be able to create an AWS IAM policy and associate it with this role. We'll also go over what that means and how to do that. You'll need to deploy and be able to deploy and manage EC2 instances from the AWS Marketplace, and create and manage AWS security groups. So those are important. And again, we're going to go into detail of what that means and how to do it. You will need an AD user account to act as a service account for LDAP queries. So whatever Active Directory instance you're using, you're going to need a service account that has at least read access to that directory. You will also need an AD user account that has access to Citrix Studio to perform the DDC, or Desktop Delivery Controller, health checks on the Netscaler. So that AD user account has to be able to log on to Citrix Studio in order to perform those health checks. It is recommended that you have a subnet hosting the VDI instances to be assigned appropriately to AD sites and services, so the nearest domain controllers may be promptly contacted. So this is important. If you have created subnets in AWS and you wanted to authenticate to a particular domain controller, but you don't add that subnet into AD sites and services and assign it to a particular site, or the appropriate site, then it's just going to contact any domain controller, and it could take, it could add a lot of time to authentication. So that's just one of several things that you can do to expedite logging onto a VDI instance that is in AWS. But that's also good practice regardless of where you host your VDI, to make sure that its subnet is in Active Directory sites and services and assigned appropriately. You should all have either a permanent or temporary demo VPX license for Netscaler. So the Netscalers that we are provisioning will require licensing, or else it's not going to be very useful. You could deploy a Netscaler VPX instance from the AWS Marketplace that includes a license, and it does come with a 30-day free trial period. Otherwise, if you have your own serial number, whether it's a permanent or demo number, you can deploy a customer licensed version of the VPX from the AWS Marketplace. And that's what we're going to do in this lab. The backend Citrix XenDesktop infrastructure should also be in place. We're going to assume that the DDC controllers and the database are already there. We happen to be using version 7.12, but any version after that should work just fine. The Citrix storefront server should also be in place, and there should also be a Citrix license server with valid XenDesktop licenses. If you do not have valid licenses as XenDesktop, then we're not going to be able to launch XenDesktop instances. And the XenDesktop image is also published in AWS as an AMI, which is Amazon's version of templates. So all those things have to be in place. We're not going to go over how to actually deploy all this in AWS. That will probably be a future lesson. Right now, we're just going to focus on how to get Netscaler working in AWS, assuming that you have a complete Citrix infrastructure already in place. Whether it's here on-premise, you could have the whole infrastructure stack on-premise and just VDI in AWS, or everything in AWS. It doesn't care from Netscaler's point of view. So let's take a look at what our environment looks like, or could look like, from a diagrammatic perspective. So this diagram kind of illustrates everything that you might want to include in a fully contained Citrix solution in AWS. So let's just go through it one component at a time. So notice that we're deploying within a single AWS region and a single VPC. So everything has to be within an AWS region, right? And within the AWS region, we're just using one VPC. The EC2 instances can span multiple availability zones for increased redundancy. So you can see how we've got storefront servers in across 2 availability zones. The same thing for DDCs and our EC2 instances. Now, for the purposes of this demonstration, we're gonna just stick with one availability zone, but it is easy to do deploy your instances or your infrastructure servers across multiple availability zones. Remember, in AWS, the subnets subnets can't span availability zones. So for every availability zone, you'll have its corresponding subnet, but subnets within a VPC can all talk to each other. The only thing preventing them from talking to each other are the security groups. But other than that, you don't have to worry about routing and firewalls, physical firewalls at least. All you got to do is make sure that you have the appropriate security groups in place. But again, for the purpose of this demo, we're only going to be sticking with one availability zone. There's also a direct connect to the on-premise data center where the domain controllers reside. So from this diagram, you can see from our on-premise data center or remote site, that's where our domain controllers are. And it can communicate with AWS and back through a direct AWS direct connect. Obviously, there could be physical firewalls in the way, so we just have to make sure the appropriate ports are open to allow for that communication. There are several subnets that are defined in AWS that you see here. The subnets are, like I said before, contained within availability zones. So different availability zones will have separate subnets. For instance, we have subnets for the backend Citrix infrastructure, right? So that's here in purple. We have subnets for, or I'm sorry, it's in green, right? The subnets for the Citrix infrastructure. We also have subnets for the VDI instances, and we have subnets for Netscaler management. This is in purple. Subnets for the Netscaler gateway, that's public user facing, and then obviously the subnets for the internal facing adapter, or the SNP of the Netscaler. So you notice that there's the prerequisite 3 subnets that Netscaler and AWS requires if you want to do HA. So those 3 are in purple, and then the green are the I'm sorry, the green and the purple. These are the not just subnets, but they also refer to the security groups. The primary Netscaler has 3 network adapters or elastic network interfaces. That's how AWS refers them to. So you can see each one is in one leg, right? You have one in the public subnet, one in the management subnet, and one in the infrastructure or backend subnet. So they're all on different subnets. You also have a secondary Netscaler. Notice that it only has one network interface, and that's all that you need to deploy it with. It needs to be in the same availability zone so that it can inherit the adapter. So the way HA works is the heartbeat it should only occur over the management subnet. And once that heartbeat is broken, or you initiate a failover some other way, this becomes secondary, this becomes primary, but the network adapters, think of them as floating adapters. They get detached from the primary, the previous primary, and reattached to the former secondary, which is now the new primary. So that's how HA in AWS for Netscaler works. The AWS security groups are shown here. So these are the ones that I was talking about that are in different color codes. So you have a security group pretty much on the Netscaler side per subnet, right? So you have a security group for the public subnet, a security group for the management subnet, and a security group for the infrastructure, Netscaler infrastructure subnet. But notice that you don't need to have a security group per subnet. You can have several security groups within a subnet. So with this infrastructure subnet, right, I actually have 3 security groups that touch it, right? One that belongs to the Netscaler, one that belongs to the storefront, and one that belongs to the DDC and the license server. And this controls, again, AWS security groups control what can talk to members of that group. So the members, for instance, the AWS security group for DDC controls what other servers, what sources, IP sources, can talk to servers that are members of this group and over what ports, and you can specify that. AWS security groups do not control what destinations its members can reach. That you have to go to the corresponding security group on the other end. So it's a different way of thinking. They can think of security groups as personal firewalls for each server, except they're distributed. So we can assume that, again, the DDC, storefront, licensing, database all already exist and they're functioning. Excuse me. So let's again look at the Netscaler deployment procedures if you were going to do this in AWS. So step 1, and remember, we're preparing or we're laying down the foundations for Netscaler HA. If you're not interested in Netscaler HA, you really don't have to do this. But in order for Netscaler HA to work, Netscaler is going to have to be able to communicate with AWS to attach and reattach, detach and attach network adapters. So we're going to create an AWS IAM policy and role for the Netscaler. The policy looks like this. So let's go to AWS first of all and see what that looks like. So if I go to however you log in, here we have single sign-on. So log into the appropriate environment, and here is a sample of what the AWS dashboard may look like. So I'm going to go under Security, Identity, and Compliance into IAM, Identity and Access Management. And on the left-hand side, I'm going to go into Policies. I have to create a policy first and then assign it to a role. Here you can see all sorts of policies, a lot of them directly from Amazon. So to filter to the ones that we create ourselves, we do customer manage. So here are a bunch of policies that we create. And you can see I've already created a policy for Netscaler. If you want to create one from scratch, you can say create policy. And you can say create your own policy, because we already know what we want. We can call it whatever we want to, right? Give it a name, a description, and here, policy document. We can actually cut and paste the contents of this into here. And then, let's see if I can do this from my notes. All right. And then you can say validate policy. Obviously, this says we need a policy name, so let's just go test, validate policy. And if the policy is valid, that means you're good. You got all the syntax and correctly. But we've already created a policy shown here. So if you look at under the JSON, which is what the format is for the instructions that we're giving, you can tell that the permissions that we're in effect allowing the Netscaler to be able to attach and detach and to view all instances and all resources in AWS. So it really just needs rights to attach and detach the network interface, okay? So once a policy is created, we need to create an IAM role for the Netscaler. So we go to roles, okay? And you can see I already created one for Netscaler, but we're actually going to create a new role. And we're going to say, okay, there are several types of roles. We're going to create one that's for the Amazon EC2 instance. So click select. Let's see, we can filter by policy, customer managed. And let's just go to the Netscaler policy that we just created. Next step, we'll call it SVC, Citrix Training NS role. And we'll just say it allows the Netscaler EC2 instance to call on AWS ENI, or Network Interface Services, on its behalf, right? And then create role. And here, the role exists right here, okay? And we'll demonstrate how we're actually going to use this role so that it has meaning to our objectives. So finally, the next step is to create security groups. So we're going to create 3 security groups that we're going to use for our Netscalers. The first is one for management, and then it'll have these rules, right? Allow all traffic from itself, right? And then allow SSH and HTTPS from wherever we are, right? And because we're on premise, right, we're going to want to reflect in our rules that we want to allow anything that happens to be in our internal network on premise to be able to communicate with this members of this security group over SSH and HTTPS. We are going to create also a public security group for Netscaler that's going to allow HTTPS traffic from wherever, everywhere, right? And finally, we're going to create one that's for the private infrastructure that will allow all traffic from itself, as well as all traffic from whatever it needs to talk to. Obviously, the DDC, storefront, VDI instances. So let's look at precisely how we do that. So we'll bring our dashboard again. So to go back to the home page, you can either click on this cube. That'll get us back to the home page. And let's go to, there's several places where you can create security groups, right? Either under compute, EC2, or under VPC, right? Let's do EC2. And then on the left-hand side, we'll go to security groups. Now, I've already created security groups for Netscaler for production, but let's go ahead and do it from scratch so you can see how to do it. So let's go to create security group. We'll give it a name. I think I have a name right here for it. So we'll call it Citrix Train, right? And we'll say it's the Citrix Netscaler Management. VPC, so every security group has to belong to a particular VPC, so we'll select ours. And as I stated before, you can create the rule for the group first and then add the rules later, or we can just create them now. In this case, we can do it now. So we can say add rule. We want it to be able to talk to itself. So basically, when you create a security group, by default, members of the security group can't talk to each other, even though they belong to the same security group, unless you add this rule that says, I want to allow all traffic to be able to talk to itself. But I don't know the security ID, the group ID for this, so I can't add it here. But we're going to do it later on so you can see what I'm talking about. But we are going to need SSH. And this I can specify right away because I know my source is always going to come from my internal network, which happens to be 10.0. Yours might vary, but for my environment, that's the way it is. And so I'm going to do the same thing for HTTPS. Okay. And then I'm going to do create. So let me go ahead and locate that that security group that I just created, which is here. You can notice that it doesn't automatically come with a name, just a group name. The name is an AWS tag attribute, but I like to fill it in. It's optional, but I like to fill it in just so that it looks consistent. Let's go ahead and edit it. So this is the group ID I was talking about. So without this, I'm not able to specify itself for all traffic. So if I go to highlight it and go to inbound, do edit, I say, hey, I want to allow all traffic so that members of this security group can talk to each other over any port. and then it's got to match this group ID. So you could, as a source, add the group ID SGC, and then it'll autofill for you. Strange that this did not take. So I don't, 000 means everywhere. I don't want everywhere. I do want, could be because I forgot to do /8. Okay, save. Cannot update. Oops, since CG03. Click on here. 03F0ABF. For some reason, it does not want to autocomplete for me. But anyway, normally it does. I'm not sure why it's not working today. But anyway, so that's the rules that you want for the management. Now let's go and create a second security group. This time we're going to create it for the public, and this one is pretty straightforward. So this is the Citrix Netscaler public facing, right? This is already the VPC we want, and we're just going to have one rule, which is HTTPS to everywhere, right? You can leave it as is, or you can just say this. I think that'll work the same way. IPv4, v6 doesn't really matter. So let's see where this is the one that was just created. So notice it does not have a name tag. So let's go ahead and give it a name tag. Okay. And if we click here, we can verify that that rule is correct. Let me sort by group name so I can see where are the new groups I just created. Okay, network management looks good. So let's finally create the last one. So the last one's a little trickier because it's going to depend on knowing the group IDs. So let's go ahead and create the infrastructure. All right, description, Citrix, Netscaler, backend, infra. Okay, I'm just going to create it right now without any rules first, right? And then, as stated before, I'm going to go ahead and find it, and so I can give it a name tag. And you can tell it has a name tag, not just by here, but if you click on tags, you can also see that it's here too. And you can add other tags you want for classification and grouping purposes, but they're not critical for functionality. So we're just going to leave it as is. But here, I definitely do want to add inbound. So for the backend infrastructure group for Netscaler, I'm going to want at least a couple of rules, right? I want all traffic members to be able to talk to themselves, right? So edit, we're going to want to have an all traffic rule. The source is that SG number, right? So it's SG993. Let's see, will it? No, it won't autocomplete for me. So F0AE6. Okay. We're going to add another rule. So it needs to be able to talk to storefront, right? And as I stated before, I already have all these security groups created for the pre-existing backend Citrix infrastructure. So this one happens to be storefront, this particular security group ID. Just to simplify it, I'll just do all traffic. There are probably clearly defined ports that it needs, but I'm not going to complicate my life. So I'm just going to say all traffic from this security group 6F4. Okay. Then I'm going to add, it's got to be able to talk to the DDCs. Let's see, is the DDCs listed here? Okay, so let me save it right now. The source needs to be a CDR block or group ID. Oops, let's close that, save. All right, let me scroll up a little bit. Okay, so I'm looking for this DDC and then one of the clients. So let's choose this client. HDX to me means that this is a this is what I've designated to be a VDI subnet. So I'm going to want this interface to be able to talk to, or the security groups, the interface that's going to be a member of this security group to talk to also the DDC and the VDI instances. So let's go ahead and do that. Let's do edit, add another rule, all traffic to our DDC, which is SG AFEC 38D3. Okay. And then finally, one last rule, all traffic to our VDI instance. So it's SG, and we're going to choose this particular VDI group, SG E0 C6119C. All right. So when everything is all said and done, there should be 4 rules, right? You're going to have a rule that allows the internal security group to be able to talk to, or to receive traffic. I'm sorry. So remember, security groups don't control what its members can talk to. It controls what can talk to it. But obviously, there has to be two-way communication eventually. So members of the internal, and here we go, the internal Netscaler security group has to be able to talk to storefront, the DDCs, the VDI instances, as well as to itself if you're doing HA. So obviously, we've just created the security groups for our Netscaler, and we've controlled what outside sources can talk to each of those security groups. But we want the members of those security groups, the Netscaler interfaces per se, to be able to talk to or initiate communication to those other components. So we got to go to the security groups of those other components and allow that traffic. So for instance, let's go to the DDC. Okay, the DDC. So let's remember this. So for the most part, these two groups don't have to talk to, obviously, they don't have to talk to anything back here. But the infrastructure, the internal infrastructure security group for the Netscaler does. So this is the only group ID I have to worry about. Okay, so I'm going to copy it so I don't have to do typos. All right, now I'm going to go to the DDC. So I want the DDC to be able to talk to. Note that you can't choose more than one, or else you're not going to be able to edit it. So the DDC, I'm going to want it to be able to accept communication, and I'll say all rules, all communication from that new security group, that internal. So you can see here, I have all traffic from my Citrix train SG infrastructure security group. So that takes care of DDC. So it will allow my Netscaler to talk to it or members of this group. I have to do the same thing for storefront. So from storefront, same thing. I'm going to edit, and I'm going to add a rule that allows. So in this case, I only need 443. That's fine. I can do 443 HTTPS from my security group. So you can see I have 443 being allowed from my new Netscaler infrastructure security group. And for what else? SQL, but SQL, we're not going to worry about SQL. I have SQL Express for this demonstration. Client, the client VDI. So let's look at the client VDI. Where are you? This one right here. Okay. I'm also going to allow all traffic from the Netscaler. So that's all traffic from my Netscaler infrastructure group. Okay, so you can see that I just added that. So now we're set. Now we've ensured that the Netscaler can talk to all the backend infrastructure servers, and the backend infrastructure servers can also talk to the Netscaler. Okay, so let's define our subnets. So obviously we need to know what networks are we going to be deploying to. Now, I mentioned before that you can create your own subnets in AWS. You don't have to, they don't have to be pre-existing. In our case, they are pre-existing. They were already created, so we're going to make use of it. So if we go to VPC, and let's at least get an idea of where our subnets are. How do we have a list of what our choices are? If we go to filter by VPC, which is useful if you have more than one VPC, and you click on subnets, these are all the subnets that are defined for this VPC. So obviously there's a bunch of client subnets and then a bunch of infrastructure subnets. The ones that we are going to be using, so remember how the Netscaler needs at least 3 subnets, right? One for management, one for public facing, and one for the backend infrastructure network adapter, right? So for management, because we didn't really create a management network, I'm just gonna go on the DB network, right? Which is normally for databases, but you can use it for anything. So the management interface is gonna be on one of the DB subnets, right? The 1A suggests that it is in a particular availability zones, and B suggests it's going to be in another availability zone. So the way the syntax here is all the A's are in one availability zone and the B's are in another. But your naming convention can vary. It really doesn't matter. So I'm going to choose this availability zone and put all the management Netscaler interfaces on this subnet, okay? For public facing, I'm going to go to, I'll just choose the external, right? So I'm going to click here, external. Now, it doesn't mean that it is exposed to the internet. There's a couple of steps that you need to put in place in order to ensure that it's exposed that we're not going to do. So it says external, that just reminds me it's public user facing, but it's not literally going to be on the internet. And then finally, for the infrastructure, the back-end infrastructure, a network adapter for the Netscaler, I'm going to use common services, okay? And again, they're all going to be in the A region, the A availability zone, which corresponds to the US East 1B, which is kind of odd that the letters don't match up, but that's fine. Now we're going to deploy the Netscaler from our AWS marketplace. So let me show you how that looks. So again, go back to the home page of your AWS console, and under compute, you can click on EC2. Okay, and then click on launch instance. Here, let's go to the AWS marketplace, type in Citrix Netscaler, and we're going to want the customer licensed version. As I stated before, you can create, you can actually request a license be baked in with the instance. They give you a 30-day trial, and after that, they'll start charging you for it. But in our case, we're not going to need that. So we're just going to do customer license. Notice how it automatically chooses the least common. This is the smallest size that you can choose for what, at least for what we want to do, right? So that makes sense. Let's just choose that, say next. You have to choose the VPC that you want to put in. Now the subnet, this is important. This is the one, what is a match? So the first network adapter, the default network adapter should be management when you're deploying Netscaler. So we're going to put it on the management network, which we already said is going to be the 1ADB network. Auto-assign public IP is disabled, right? So we don't want any public IP capability for this. IAM role, okay, this is important. Here we're going to choose that role that we created. All right, this is how Netscaler talks to AWS when it's in the middle of an HA cycle. It's able to detach and reattach network adapters using this role. So we don't have to enter user a AWS service account or anything of that nature. This role takes care of all the permissions it needs. And now network interface, right? So we obviously, I just said we needed 3 network interfaces, right? But we're only going to launch with 1, and we'll create the other 2 and attach it later on. So this one is going to be the Ethernet 0 is going to be the management interface. You can either have the IP auto-assigned, or in our case, we're going to manually assign it because I already have predefined scripts that allow us to configure it very quickly, right? So you can, have it auto-assigned or put your own IP there. If this is not on the same subnet as this the subnet that you specified, then it's going to tell you. But it didn't tell me anything, so it must be valid. The add storage, we'll leave it as it is. Add tags here. Again, tags are optional. In our environment, they are not. So I'm going to go ahead and add the appropriate values, keys that I need. Let's do 001A, AQA, AVA, IF. Okay. And again, this is just arbitrary, but I do have a naming convention. And again, if you have particular tags, again, none of this is functionally required, but it sometimes, if there's a governance or some other reason that you need the tags, this is how you would put them in. Platform is Citrix, and client, we're going to make it generic. Okay. Next, security group. So you can see how the template already comes with a lot of default ports, and this can get very confusing. So I think it's far simpler just to know exactly what you need them for, what ports you need. So that's why we create the management, but I'm going to use the one that we just created in this lab, CTX train management, right? These are the rules that we need. Review, and it's just some reminders of the summary of what to expect, and then say launch. Now here, this is important. Every time you launch an EC2 instance, which is a virtual machine in AWS, it's going to associate it with a key pair. You can create your own, or you can select one that is already there, that you have already created in the past. Now, if you create your own, you have the opportunity to download that key, the private key, but that's the only opportunity you have to download it. If you lose it, then you've lost it. It's impossible to retrieve it again. So make sure you save it. Here, I've already saved this private key. I know it works. And the private key with respect to the Netscaler, this is going to be your password, your NSRoot password. So if you don't have this, then you can't log into the Netscaler launch engine. So the default password for the Netscaler in AWS is not NSRoot, right? The default NSRoot password is that private key. And we will show you how to actually use that private key to log in. So that's the first one. Let's go ahead and launch a second one because we want to demonstrate HA. So I'll go ahead and launch. Again, it's pretty much the same exercise. Scaler. Okay, customer licensed. The default size that's set to us is going to work for us. We're going to choose, and remember, it's got to be in the same availability zone for Netscaler. It can't span availability zones because by virtue of how it does HA, and we'll talk about the impact of availability later on. Okay, auto assign public IP, no, we don't want that. We do want to assign the IAM role that we created, and we do want to give it a IP that has been defined for us. Okay, and click next. Add storage is fine. Add tags. Get name. We're going to call him B for the second Netscaler. Okay. Business region is in North America. The unit. Platform, and again, all of this can be scripted fairly easily. So if you're doing a massive amount of deployments, you don't have to go through this monotony if you don't want to. Security groups, we're going to select the same security group. Okay. Review and launch, and we're also going to choose the same key. And the Netscaler launches pretty quickly. It's surprising how quick the instance will be ready for you. So you won't have to wait long. Here, obviously, you see a whole bunch of them. If you want to filter by just what you care about, if you just type in the first couple of letters of the name, then it will filter accordingly. So it's pretty intuitive that way. So let's go ahead and we'll wait for these to come online. Let's go ahead and see what our next step is. Okay, so here, so we already did all these steps. We defined our AWS subnet. So here's a good screenshot of what are the networks that we're using for the purposes of this lab. Also notice that our Active Directory controller, so this will be necessary to understand the routing table on the Netscaler in AWS, right? So it's got to be able to go to all these locations, but it also has to reach back into our internal network, which happens to be this. That's where our Active Directory controllers are located. So they're not in AWS, and if that's the case, we have to modify the routing table on the Netscaler so that it knows where to go in order to communicate with the Active Directory controllers. Now, this assumes, of course, that our direct connect is configured properly and that our network team has provided those routes on the network side, right? Those routes are in place. We just have to tell the Netscaler to use them, right, in order to navigate to our domain controllers. And that we'll demonstrate later on. So here is how we just did. We deployed 2 Netscaler EC2 instances from AWS. The default network, I didn't use DHCP. We could if we wanted to, but I chose to use predefined NSIPs. We just used a pre-existing key pair that already had a copy of the private key. And now we have to apply license. So to apply the license for your Netscaler, right, notice the NSIP of it. So if you go and you launch PuTTY or any SSH program, or SSH program that you have, and you go ahead and, so this is how you connect to the Netscaler. Remember I told you that the NSRoot password is not NSRoot, but it is the private key. How do you get it? So the private key, when you save it, looks like this. Let me just give me a second to bring it up for you. Okay, so the private key is going to be a PEM file, right? So in this case, that's it, right? PuTTY though can't use a PEM for authentication. It needs to be converted to a PPK, which is native for PuTTY. It's native for WinSCP. So in order to do that, PuTTY has a utility called PuTTyGen that allows you to take this and convert it to this. The instructions are on AWS. If you go here, for instance, when I was doing the first time, I clicked here and I say connect, it kind of gave you instant directions. So it says if you're going to connect through PuTTY, right, it brings out these instructions of how to convert your PEM into a PPK file, right? But we're not actually going to do that. You can follow the directions. It's pretty straightforward, right? I have already created a template for this key, right? So it's called training VPX, right? So I'll load it. If you're doing it from scratch, you're going to want it, first of all, specify the host name as nsroot@ and the IP of your NSIP. So in this case, it's 2.165, right? 168.2.165. And then in SSH auth, right? This is where I browse for the PPK key, right? So it's right there. And that's it. That's all you need in order to log in. And then once this is set correctly, and I know I have the correct key, I go do open. It'll ask me a question, first, and then I'll get into it. And that's it. I'm connected to this Netscaler. I like to see the color, so set CLI mode color on. So the output is color coded. You got to go to shell first, and then type in lmutil host ID, and that'll get you the host ID. I'm going to make a note of that, and I'm going to paste it in wherever I'm tracking this information. And I'm going to do the same thing for the second Netscaler, right? So I'm going to go ahead and load my pre-save settings, and then change the IP to 2.57. That's my secondary. Open. Okay, I'll do the same thing here, set CLI mode color on. And then I'll go to shell mode, lmutil lm host ID and make a use of this. So I need this for the licensing, right? Because I need to generate a license file for the service. So in order to generate the license file, obviously you need to go to my Citrix, right? And you either need to specify the license key that you have, right? The serial key, or if you're using the same serial key for demo purposes, you need to reallocate that key for your Netscaler. So if I go to all licensing tools, if I do a single allocation, I can do that and just enter the license code. But if I already have a code that I've been using and reusing for demo purposes or experimentation, then you can just reallocate that. Because I have so many, I'm just going to filter by VPX. That'll get me closer to, and I'm hoping I still have enough time left on this 90-day trial period key. But that's the code, right? And I want to reallocate it. So you can see the host ID. These are the past experiments that I've done. I need to enter the one of the host IDs so that I just retrieved. So I'm going to copy the primary, or the first one, which corresponds to the primary. I'm going to paste it here. I'm going to say continue, confirm. Okay. And then I'm going to save the file somewhere. Okay. Training NSA save. And I'm going to do that for the second one as well. Okay, so I've saved both files to my hard drive. Now I need to upload it to each Netscaler. I'm going to use WinSCP. Now WinSCP works very similar to PuTTY in that you still need that PPK key. So I'll show you how we do that. I have a preset for training. So I'm going to edit that. I'm going to connect first to my primary. So here you can just put in the host name, the NSIP here. Pass the username is NSRoot, but you won't have a password, right? Instead, go to advanced, go to SSH authentication, and you just browse for the PPK key here. And that's all you need. So I'm going to go ahead and save this, log in. That's fine. It was looking at a directory that doesn't exist in this yet. So here's my root. I'm going to go to nsconfig license, right? And here I'm going to go to where I stored that. Now you can't just mix and match the license keys, right? Each license key is keyed into the LM host ID, right, for the Netscaler. So this one I know corresponds to this particular Netscaler, right? Copy it to license, and then you're done. I'm going to go ahead and connect to, I'll disconnect from him. I'll connect to the other one, which is 57. Save, log in, same thing. Okay. This time I'm going to go to B, this license file. I'm in Flash NSconfig already. I'm going to copy him to his license folder. All right, then I'm just going to exit. Now, there's probably a way to reread the license file or something like that instead of rebooting, but since reboot is really easy, I'm just going to reboot both Netscalers. Okay. And then we'll confirm later on to see that the license did take hold, but we'll do that later. So while they're rebooting, and the reboots actually are quite quick for the VPXs in AWS, so that's pretty cool. But let's go back to our presentation. Now we need to create those other additional network adapters that we talked about, right? So we already have one for the NSIP. We need one that's associated with the public-facing access gateway, and then one that's associated with the backend infrastructure, which is also the SNIP, right? Let's go to back to the AWS dashboard. So we're already in the EC2. If you're back here for some reason, the home page, just go back to EC2, or here, the recently visited sites will be here. However, wherever you are, just make sure you're on EC2, right? And then on the left-hand side, go to network interfaces. This is where you're going to create additional network interfaces. But let's, for the sake of order, let's look at the interfaces that we already have associated with those, the new Netscalers that we just deployed. So if I sort by here, by security group, I'll see, so these are the two, right? These correspond to the Netscalers I just deployed. But it doesn't, there's no name here. So it can be kind of confusing which, which one is which. So I'll click here, 49E corresponds to B, right? So let me go ahead and copy the string here. I'll go back to network interfaces, 49E, U must be B. And then the other one's got to be A. All right, and I know that these two are the ones that I deployed because these are the only ones that have this security group. If I had more that were in the security group, then there'd be other things that I have to do to make sure it is what it is. But for me to confirm that this is 1A, the one that I in the lab that we're doing, or the demo, I click on the instance type, and yes, it is definitely 1A. So I'm good there. Okay, so we'll go back to network interfaces. So for 1A, we're going to add 2 more to him. Right? We need to create 2 more network interfaces, and those are the ones that are the floating adapters. In an HA event, they would just migrate to 1B. But here, let's go ahead and create a network interface. Description, we're going to call it NS public, right? Now, description is not the same thing as a name tag. We'll add the name tag later on, but that's fine. Now, the subnet's important. Remember, we wanted external in the first availability zone, so we did 1A external, and we have to associate with security group. Well, we just created one, right? Citrix train for public, right? So we'll select him, and the IP, we could have it auto-assign, but I already have IPs that are associated with a script that we can use to quickly configure the Netscaler. So this is what it's expecting, 168.4.26. And again, if it's not a member, if it's not part of the subnet, then there should be an error. But no error means that it goes through just fine. Okay. And notice that the one that I created is going to show as available, meaning that's not bound to anything. So let's go ahead and see if we can find out. Here's one, right? So it's not bound to anything means it's available. So I'm just going to copy the description. Let's see, this will allow me to copy the clipboard, and then I'll paste it in the name tag so I know that it's there. I'm going to create another one. This one is going to be that backend infrastructure adapter. So we'll call it something descriptive like that, infra. Subnet is the common services, right? 1A, that's what we agreed to use. And then the security group is the one that we created for our training, CTX train infra. Okay. Now, the first IP that it provisions, say I just let it auto assign, it's going to be the what I would associate with the SNIP, the SNP. But since I already have a set of IPs that I prefer to use, I'm going to use that instead. And again, if this was not in the subnet, if I mistyped it, it's not in this subnet, then it should give an error, but it doesn't. So here is the one that I created. And you can see that it's also available. And I'll add this to Citrix train. So if I wanted to filter in, there's just all these adapters I don't care about. So if I do CTX train, right, it'll just show me, and it'll filter in whatever characteristic. It's not any particular characteristic it's filtering on. But these are the adapters that I'm interested in, right? So the adapters corresponding to each management IP, right? Management interface for the primary and secondary, as well as these floating adapters. And you can tell that these two are not bound to anything yet, right? So let's bind them. You can bind them here, or you can bind them under instances, right? So let's go under instances. I want to bind both of those adapters to this Netscaler, right? But I want to do it when they're powered off. And I want to do it in a specific order, only because that's how my scripts work. And we'll go into detail later on what that means. But let's first attach to each of the Netscalers just to see if the license took hold. So if I go to load my training template connection, I go to the first one, okay, and then I say show license, right? Everything should say, most of it should say yes, right? If it all says no, then it means the license didn't work. And it shows it's a platinum type. So I'm going to exit there, and I'm going to shut him off. Instances stop, okay? And then I'll connect to the second one, which is 57, okay? Load you 2.57 and say same thing, show license. Okay, everything looks good. I'm going to exit out of you, and I'm going to also shut you down. Stop. So make sure you don't terminate. If you terminate it, then that deletes the virtual machine unless you're ready to get rid of it. But stopping and starting is those are functions or reboot, right? Those are all valid operations that you may engage in while managing the Netscalers. Also note that because they're using elastic block storage, it's going to remember the settings, the disk. It's not going to wipe anything. So you can take comfort in that. Sometimes you have to hit refresh to get the true instance state. So it's stopped. I'm now going to start attaching the network adapters to 1A, which is going to be my primary. So if I go to Actions, Networking, Attach Network Interface, right? You can see that I can only see a select few. I can only see the ones that are in my availability zone that, and subnet that is, I'm sorry, I can only see network adapters in my availability zone that are available, right? So in this case, I'm going to choose, I'm going to bind my public first and then my infrastructure. And the reason why I'm on my public first is because I want this to be the second network adapter enumerated and all the adapters bound to 1A. Attach. And that is only because that's the way my scripts work. I don't know if it really matters, but I try to keep track of these anyway. So I do networking, attach network interface, and then I attach the infrastructure, the private infrastructure version. So now it's got all three network adapters. And if I go to network interfaces, right, and this is already filtered for me, I can see that they're all connected. And if I filter by instance ID, it shows that the two that were floating are now connected to my first instance because they all match here. So that's good. So I go back to instances and I'll restart this guy, start. So in summary, we attach the public interface that has the subnet and security group associations, and we did the same thing for the private interface. We attached private interface, which had these associations to it. So here, this is important. So now here I say associate additional IPs to the NS private infrastructure IPs, right? So remember, in our when we're going to create VIPs on the Netscaler that hosts DDC and storefront. That you do that if you have multiple instances and that you want to load balance between them. So that's pretty typical. Normally you would just publish it on the Netscaler, and if the Netscaler is connected properly to the switch, then it would just broadcast those IPs. In Amazon and AWS networking, it doesn't quite work that way. You do need to publish the VIPs on the Netscaler like you normally do, but they're not necessarily going to be, or they're definitely not going to be reachable by anyone else until you also mention those VIPs in the network interface. So for instance, if I go to network interfaces, this infrastructure, this corresponds to the SNIP. This also corresponds to all the VIPs that I publish on the Netscaler that the backend service need to communicate, and so on and so forth. So if I click here and I do actions, manage IP addresses, you can notice that this is the IP that I am associating with the SNIP or the SNIP. I'm going to add additional ones. In fact, I'm going to add 3 more. One for my Active Directory VIP, one for my storefront VIP, and one for my DDC VIP. And they're all going to be on the same subnet. Okay. So my Active Directory VIP is here. And I can auto-assign. If I auto-assign, it would automatically just populate it with any available IPs, but I have ones that I know that my script uses. So I'm just going to stick with that and do yes update. And then, this confirms that these are the ones that you assign, and then you can just do X to get out. So those IPs are now associated with it. They're not accessible. You still have to create the VIP on the Netscaler, but without doing that exercise, the VIPs that you create on the Netscaler, even though they have valid IPs, won't be advertised without you putting it on the network interface itself in AWS. So we've associated with that. And here it says, and here's the attachment. So you can associate those IPs before or after you attach it, doesn't matter, right? So like I said, I first attached the public interface. So that becomes Ethernet 1, right? Ethernet 0 is the management IP interface. Ethernet 1 would be my public, and Ethernet 2 would be my private infrastructure network adapter. And then I'm going to make sure that both of them are on. I can go ahead and turn on the secondary as well, because I'm not binding any more network adapters to him. So I'll just leave him on so he's ready when I need him. But for now, I want to configure the primary. So let's go back to our presentation. All right, so there's a couple ways. You can do it manually through the GUI, or if you have a deployment script, you can do that. And that way, that'll be much quicker. I am going to use a script, right? So one that I already created, so we can set up the gateway fairly quickly. But I can show you kind of where, what it is. It's really not that difficult. Let me go ahead and show you what that script looks like. Okay, so this is what the script looks like. All right, so again, a lot of this you can pull from an existing Netscaler that's running the way you want it to. Here you can see a lot of these commands are making sure that I have the management groups configured, that I have some of Citrix's best practices put in place, right? That I have the certificates added. Again, some of these are not things that you necessarily need. A lot of these are, I guess, respond to HTTP, HTTPS redirect, which we really don't use, but we put it in anywhere anyway. If you have log forwarding, app flow enabling, those are some of the commands that we put in here. Binding your own certificates to the management interface. What else? Monitors. Interfaces, so on and so forth. Here, this is interesting though. Here, this is where I mentioned where it mattered which order my network adapters were configured. I wanted 1/2 to be associated with public, and here you can see I associate the public IP with 1/2. This VLAN is descriptive. There's no real VLAN 260 in AWS that I need. So it's just really there just as a placeholder. But I am associating 1/2 with the public IP or public-facing IP. This is the gateway or the gateway IP, 168.426. Right. I add my servers that I'm going to use for my VIPs. You can see here I have only one DDC and one storefront server, but you can have multiple ones, right? Because I'm actually creating a VIP and then putting these members behind them. Again, creating the authentication policies and the session policies, right? They're all there. Ciphers, right? If you don't want to use a default cipher, which I highly recommend you don't, you can create your own ciphers, and that will harden your access gateway. Adding the NTP servers, I think there's some binding the certificates, right, to the right VIPs that require them. So we're securing DDC. So DDC has to be SSL. storefront is SSL. Now, obviously, your access gateway needs to be SSL, or else it's not going to work. So that's where we bind the certificates here. I think up here I also added a custom theme. So I'll show you. I'll have to copy those files manually. Now this is important. So I add some DNS records to the local Netscaler, kind of like the host file for Netscaler, because I don't have it in my public DNS. Since this is a lab environment, I'm not going to modify my public DNS if I don't have to, or my production DNS. So here's my storefront URL, or the storefront host. This is what my certificate's associated with. So I make sure that that's in place, right? Pointing to the VIP for storefront. And same thing for access gateway. I have that there. And here, this is important. So these are the routes that I was talking about. Let me see if there's a better description here. The routing table. So remember, I was talking about the routing table. When Netscaler, you deploy one and you don't make any changes to the routing table. By default, it's going to look like the block that you see here, right? The default route will be your NSIP gateway, right? Then you'll have your private infrastructure, right? Your backend, your SNIP network, right? That will correspond to your SNIP itself, right? Your SNP. Management network, your management network will correspond to your NSIP, and then your public network will correspond to your access gateway IP. So these are the routes that it knows. But if you have other routes, like for instance, my domain controller, it's not in any of these routes, right? Now, it can probably get, the Netscaler can probably get to the domain controllers through the NSIP gateway. In my case, it probably will work, but that's not how Netscaler communicates with the domain controllers if I have them behind a VIP. So if I create a VIP on Netscaler for my domain controllers, it's going to want to communicate out my my private, the private infrastructure network interface card, right? It's not going to want to communicate outside the management interface. So this route is not going to work. Even though it's reachable, it's not going to use it, right? That's why I create another route, right? Hey, if I want to get to my domain controllers or my internal resources, right? Make sure the subnet is, the net mask is appropriate. I'm going to force it to go through my SNIP gateway, which corresponds to the private infrastructure network interface card, the SNP, right? So remember, if you're using a VIP on the Netscaler to talk to your backend servers, it's going to use the SNIP interface. So you're going to want it to tell it to use the SNIP gateway. Same thing for the other VDI subnets. If I have VDI subnets that are not mentioned here, it's got to go through the SNIP gateway, and so on and so forth. So that's important, or else it's going to fail. Your Netscaler is not going to work. So in summary, this is our configuration. So in our configuration, for instance, if our NSIP was this, right, our NS gateway was this, NSIP gateway was 168.2.1, but our SNP is 168.0.208. Our SNP gateway, in this case, is 168.0.1. Obviously, we're assuming a /24 subnet. But again, it all depends, right? But you want to just make sure that you have mentioned your NSIP gateway. You know what that is, right? And then in our case, 10.5.0.0 is where our the network where our domain controls are. I'm going to say go through 168.0.1, the SNIP gateway, to get to it. Same thing for VDI. Our VDI networks, even though it's in AWS, 168.32, let's pretend or assume that that is in AWS, right? I still have to tell it to go through my SNP gateway and not through the NSIP gateway, okay? So make sure that those are in place. And that's kind of what I have mentioned here, right? So I have those routes mentioned. I have other routes, but those are the ones that are critical, right? So let's go ahead and connect to the primary, right? So here's a couple of, I need to first copy the SSL files to the primary. So remember, the script mentions binding the SSL certificates or importing the SSL certificates. That's not going to work if the SSL files aren't on the Netscaler already. So let's go ahead and do that. And again, because I've already preset some of this, it's going to, there's a lot of steps that I'm not detailing, but I'm assuming that you have a familiarity of how to create and upload SSL certificates to the Netscaler. So let's say that you already have them. In my case, these are all my SSL certificates, right? I'm going to go, I'm already in Flash and Sconfig, that's where I want to be, and this is my SSL folder. I'm going to copy all of these guys to him. Yes to all. Okay, and then I'm just going to close it. That's all I need right now. Then I'm going to connect through PuTTY and run the command lines to configure. So let's go ahead and do that. .165. So here are all, here's a command line. Let me just get it bigger so I can see if there's any errors. And let me go ahead and start copying sections of it. You can actually copy all of it at once if you're sure that there's no errors. I'm just going to copy all the way up to my certificates just to make sure that my certificates go through no errors. So you can see here that because I just copied those SSL certificates, it's able to import them with no problem. You might see some red here, but they're just notes saying, changing the time zone requires a reboot, which is fine. So I'm going to go ahead and copy the rest of the config, assuming that I'm going to assume that it's good. All right, now some of the red is there. I already know what they are, and they're not critical. Okay, save. All right. Now remember, I have a custom theme. There's no way to mention the media files in the command line, so I actually have to upload the media files. But I needed to create the theme that I want to use first before uploading it. So let me go ahead and start WinSCP again. I'm going to reconnect to my Netscaler. And here's what I'm talking about. So if I go to the root of the Netscaler, var Netscaler, log on themes. So I created a modified X1 theme called X1 Connect, and I actually have media files that I want to use. So if I copy that to here and overwrite the existing, again, this is optional, but I just have some bitmaps that I prefer to use, so I'm going to copy it that way. And I am going to reboot. Now, the older versions of Netscaler required reboots. This one probably doesn't, but I'm going to reboot anyway. Yes. And then we will test. We will test to make sure that it's working. Okay, so it says here, copy any remaining files, custom themes, and then reboot. Here it says, once it comes back up, we're going to make sure that all the VIPs are green, right? Verify the STA status. This is important. Make sure the STA status in the Netscaler is green. And here's just some other things. So let me show you the environment that we're talking about, right? So this times out from time to time, but let me just go ahead and connect. So remember, I mentioned that the backend Citrix environment should be up and running. So here are some of the ones. Let me kill this filter here so you can see all the instances, right? So for our lab, this is a license server, he's on. This is the storefront server, he's on. And this is the DDC. So we can see both of those are on, okay? So let's go ahead and log into him. So I'm gonna make sure that he is running. Well, actually, I can connect his IP or the host name because this guy happens to be part of the domain. So I have him in DNS. Okay, so let's go ahead and start Studio. Okay, so this guy is in AWS, so, and the instances are in AWS. So not going to details now, but if you look at hosting, you can notice I do have a host connection of Amazon EC2 type. So that's how it all is able to work. Now I'm going to make sure that my power management reflects that they're supposed to be on. Okay, so if I double click it, I can see both of them are registered. So I should be good to go. One of the things that you're going to want to make sure of is, if you go back to the presentation, for the purpose of the lab, right, we want to make sure that the storefront servers can resolve and access the DDC, because the storefront server is actually using the VIP that I created for DDC over 443 to retrieve farm information, right? So if I log on to the storefront servers, let me see if I have it pre-saved here somewhere. Looks like I do not. So let me go ahead and desktop. So I want to be WQA. So I'm just going to log on to the storefront server and show you what I'm talking about. So once that's it, because remember, I want the servers to be using the VIPs on the Netscaler. So if I load up storefront, and then let me load up the host file. Notepad. Okay. So if you created your store, right, and your delivery controls, you mentioned this VIP, right? So it's going to try to do it over 443, right? You have to make sure that it can resolve it. And so if it's not in DNS, I just put it here, right? Just to make sure, and that corresponds to the VIP on the Netscaler. So that's how we know that that's going to work. Okay. We want to ensure that the delivery group and the VDI desktops are available. We just did, right? They're all registered. And then we can test launch it. Right now, I'm probably just going to go through the HA exercise before I test launch it, just so that we can get that out of the way. So let's go ahead and log into the Netscaler. So here, all right, he's probably rebooted already. I'm just going to go to the GUI. I can do it through the command line if I want to, but I'm just going to do it through the GUI to show you how that works. 2.165, I believe that's it. Okay. Now remember, you can't use NSRoot, right? Because the password NSRoot is the private key, and there's no way to pass that through the GUI. You can create another local account. I did. I created another local account in Citrix. And I also LDAP integrated, but I don't know if LDAP is working, if the VIP's not working. So I'm just going to log on as a local account. Just make sure I know the password, right? And then see, just double check and make sure all my VIPs are working. You can skip that, right? Go to Traffic Manager, load balancing, virtual servers. Hey, look, they all look like they're up and running. So I should be able to log on with my Active Directory account if I configure this correctly. And looks like it's going through. So I know it's communicating well. I had the routing table adjusted appropriately so that it can reach my Active Directory servers through the SNIP interface, right? So you can see everything here is green. I'll just hit save here. For some reason, it thinks that there's configuration that's yet to be saved. If we go to the Netscaler gateway under virtual servers, internal access. So this is the access gateway IP that we're going to be testing. That users hit in order to log into the Netscaler to launch Citrix. I want to make sure that my STA is green. So I go here, it looks like it's up. That's very popular. When you get problems, sometimes this is because it's down. So you want to at least do a check to make sure that that is working right. And if I go to the access gateway IP, so if you look here, So obviously to test launch, we want to make sure that our workstation can resolve the certificate, whatever certificate that I put into the and associated with the gateway IP, access Netscaler access gateway IP. So I have that in place on my local host file. So if I go to, it should be able to bring up that page right here. So that's fine. But like I said, we won't test the launch right now. Let's just do the HA first, so I can kind of demonstrate, because that's really the focus, is just to make to show you how Netscaler works, to deploy it in AWS, and to test its HA capabilities, which is pretty cool. So I'm going to log out of here. Okay, so we've already confirmed that that works. Let's go back to our presentation for HA. So to complete HA configuration, this is kind of what we're doing. It's kind of like a dance between the two instances, right? On the primary, or whatever you want to be the primary, you're going to enter the command add node 1 and the IP address of the secondary. On the secondary, you're going to do the same thing, add node 1, but then the IP address of the primary. The order you do this is very important. If you do it in the wrong order, you're going to overwrite your configuration, your NSA configuration, with a blank one. And that would be not very helpful. So make sure that you run this command on the primary first, that you add the secondary, which should have a blank configuration. Then on the primary, you're going to set that communication relationship, set RPC node, and then the password can be anything. It doesn't have to be the NSRoot. Well, obviously, it can't be the NSRoot password, but it doesn't have to be any specific password of an account that exists on the Netscaler. It just can be any random string. They just have to match. So set RPC node for the primary, set RPC node for the secondary. On the first Netscaler and the second Netscaler, you'll run the same exact commands, and then you'll sync the files and set HA node to the best practice, and so on and so forth. So let's go ahead and do that. You kind of see what I'm talking about. I just want to check something really quick first. Okay. So let's bring up both of those PuTTY sessions. All right, so I'm going to start load. Remember, the primary is 2.165, right? Open that, and I'm going to put him on the upper left-hand side. And then I'm going to open up another PuTTY session. Same thing, going to load the connection template, and then log on to the NSIP of the secondary. So the top is primary, the bottom is secondary. So let's just not confuse the two. Okay. And then based on the steps, we said add node 1, right? 100.68.2.57. So that, is the secondary, 168.2.57. And if they can talk to each other, then it should be not a big deal. So we're going to do the same thing for here, but add the other IP on the secondary, 168.2.165. So he's going to return the favor. Then we're going to set up the relationship, set RPC node. And then now here you can just type in the primary address again, 168.2.165, password. And we'll just do like something silly, like I don't know, 123. All right, and then we're going to do the same thing. RPC node, 100.68.2.57, password. 3. Make sure that that's correct, 162.57. And we'll do the same thing here. Set RPC node 100.68.2.165, password. Make sure it's the same. Okay, RPC node 100.68. Now, yes, you can do this through the GUI, but it's my experience that command line is far more stable. So that's my recommendation, and it's really not a big deal, right? So if I do show node, let me just expand this a little bit. So nothing should say unknown, right? Everything should show you that it's working. Primary, it's got all those interfaces. Secondary, it's just got one, but it's still able to replicate, right? On the secondary, if you do sync HA files all, whoops, sync HA files all. Okay, and the primary, let me just remind myself what the command was. Set HA node failsafe on. Okay, set HA node fail. It doesn't matter. Failsafe on. And then I'm going to save the settings here. Obviously, we're going to want to do the same thing to the secondary as well. Make sure that that setting is set correctly. So on the secondary, I'm just going to paste these commands, right? Now I pasted a couple of them. Most of these is for cosmetic, right? But this is really the set HA node failsafe on. That's the only one that I really want to make sure that that's in place. And then I'll do save C. Okay, and then I'll reboot him. Again, I'm not 100% sure I need to reboot, but in the past I've had to. This version I don't think we do, but we'll just go ahead and reboot anyway, and we'll wait till that one comes back online. Now here's an important fact. So 1.1 is obviously the only way the Netscalers can communicate with each other, right? Because that's the only, those are the only interfaces that are on the network. Well, they're all the interfaces on the network, but 1.1 is the only pathway that the primary and secondary can communicate with one another. Because 1.2 and 1.3 are only owned by one and not the other. So it doesn't make sense to send heartbeats on 1/2 and 1/3. In fact, I've discovered that it actually complicates things. So you're going to want to shut off heartbeats on 1.2 and 1.3. If I do show interface 1.1, with this management network, you want it to have the heartbeats, right? But if I do show interface 1/2 and 1/3, you can see it automatically has heartbeats. We want to shut those off. So the command is set interface 1/2 heartbeat off and 1/3 heartbeat off, right? And so if I do show interface 1/2, it doesn't have a heartbeat anymore, right? But and neither does 1/3, but 1.1 should still have a heartbeat. Okay. When you fail over, right? So the secondary becomes a primary, it's going to turn those heartbeats on again. And that's just the way it is, right? Or if you reboot or whatever, those heartbeats are going to go on again. So you need to remember to, so that's why there's a lot of things with Netscaler HA in AWS. It's not as stable as I like it to be, and it's kind of flaky. That's one of those things. You have to make sure that those heartbeats are off, or else failover may not occur correctly. And there's a couple other things that we'll review to make sure that, to better guarantee that your failovers will be successful. So let's do show node, see if the secondary is up again. So we can see that secondary is up again, and that, and you can see here, it says for sure that HA is off. Heartbeat is off for the other interfaces. 1.1 is the only one where monitoring is on. Monitoring is never enabled on 1/2, 1/3 either. So that, at least it's smart enough to know not to monitor that. So if we go to, and I'll show you pretty quickly, 100.68.2.165, right? Oops, that's not my elevated account. So if I log on to the Netscaler and I look at the interfaces, so under System, Network, Interfaces, right? I'll see that HA monitoring is only on the management interface, which makes sense, and it's always going to be off on everything else. But the the HA monitoring, it's always going to be off. But heartbeats, it'll try to flip the other interfaces on all the time when there's an event that occurs. So you got to make sure that that's off before the next failover event in order for this to work right. Let me just save the settings here. And let's go ahead and do a failover so you can kind of see what happens. Okay. So one of the things that for successive failover to occur, right, the secondary has to have only one enabled interface, one. Makes sense, right? It's the only interface that's connected to it. And then the primary has to have all of them, right? And you have to have the monitoring heartbeats disabled on the other adapters that are not relevant for heartbeat. If any of those things don't occur, then failover could fail, or it just won't work. So make sure that that's the case. If we look at okay, so in order to illustrate HA working, if we go back to the AWS dashboard, the EC2, so if you're in the dashboard, you just go click on EC2, go to network adapters. Now you can filter just so that you can see the network adapters you want. So right now, all three are associated with the 01A. And eventually we want these two adapters to detach and reattach to 1B. And the instance ID will tell you who owns what. So let's see if that actually works. I believe I've identified all the variables that could prevent that from working, but let's see. So we've already disabled the heartbeats, right, on the non-relevant interfaces, and we've confirmed that the secondary only has one interface that it shows. So we do force HA failover, say yes, and we just wait a few seconds. And ideally, what should happen is these two floating adapters should detach and then reattach to this instance. And you can see how one of them is already becoming available, meaning it's in the detachment reattachment process. This one should shortly also become available. Okay, that's good. And then if we wait just a few more moments, we should see it slowly being attached to the 01B, which corresponds to instance ID 49E. So we can see that all the adapters are up again, but this time the two floating adapters have attached themselves to the second network, the second Netscaler. So we can see that the failover has occurred, at least from the network interface perspective, successfully. We go back to the PuTTY session. Sometimes it's just aborts, the connection aborts on the former primary. But it doesn't. Let's just go back to create a PuTTY connection to this the new primary, which is 2.57. Okay, and then here let's do a show node. So you can see that 165 is now secondary, and there's only one enabled interface, and then you have these two, right? But if you notice that the heartbeats are now on again. If you go to, for instance, if I do show interface 1/2, it shows that the heartbeats are up again. So for every failover, right, whether it's scheduled or incidental, you have to remember to run these again on whatever is the primary to make sure that those heartbeats stay off. Now, occasionally, and we're going to fail back to see if we can replicate this. Occasionally, the secondary will still retain 1/2, even though 1/2 already moved. If that ever happens, the failing again won't work, right? You'll have to reboot the secondary if there's more than one interface, one enabled interface. Once you reboot it, basically you shut it down and start up. If you reboot it in AWS, it might hang. You have to shut the instance down completely and then start it back up again. And then you'll see that it'll go back to just having one interface. And then the failover should work. So let's go ahead and fail it again so that you can kind of see it working again. So we've already shut off the heartbeat on the interfaces that are irrelevant, and we've confirmed that the secondary does have only one interface. And if I could do force. Actually, before we do that, let's double check to make sure that the page is still accessible. So if I do HTTPS, AWS 1, you can see that I can still load the page, so that's great. Let's go ahead and fail it back just to make sure that it still works. Force HA failover, yes. And eventually we should see the same thing. The floating adapters should move back to the first Netscaler instance that we deployed. So as we can see here from the adapters, that everything's failed back the way we anticipated it would. So all the adapters are, the floating adapters are associated with our first Netscaler, which is now the primary as well. We can go ahead and test the desktop launching. So if we go to AWS Connect, log in. And then we can go ahead and try to launch your desktop. I'm going to save this to my desktop. Go ahead and launch it. And let's see what happens. Let's bring this up over here. So here we can see that we've connected to a desktop, and it'll just be loading the profile. I haven't perfected the login delay for the lab yet, so it's going to take a while. I'm just going to pause the recording so that we won't have to sit through this. Okay, so we can see that the desktop has loaded. Let's go ahead and do a failover, see what happens. So if you recall, I'm connecting by PuTTY to the primary, right? So if I do show node, okay, we can see that that's primary, there are no errors, and I only see one enabled interface on the secondary, so that's cool. I have to shut off the heartbeats, if you recall that's something that we still need to do. So let's go ahead and do that. Okay, show interface 1/2, just make sure that, okay. All right, good. So let's do a force HA failover. So now the first Netscaler will fail over to the second. And the anticipation is I'm going to lose connectivity. It will try to restore connectivity, but my experience is it's never actually, I think only once did it restore connectivity before disconnecting altogether. But generally speaking, it's probably just going to drop it, and then we have to reconnect. So while that failover is occurring, if you look at some of the summaries of what we did, shutting off the heartbeats on the primary instance on the interfaces that don't need to have them, and the note that when you reboot the instance or failover occurs, you're going to have to redo this again. We're testing failover. We've already witnessed how the ENI associations change from primary to secondary when a failover occurs. Now, while that's occurring, there's a kind of limitations. Obviously, well, there's more than just a couple limitations with the Netscaler HA in AWS as we described it in this recording. Here, notice that the native Citrix HA will only work if both Netscaler instances are in the same AWS availability zone. That kind of flies into the face of the convention of distributing your assets across availability zones to provide better redundancy, better availability. That's the whole point of having the AZs. So if the Netscalers can only be on the same availability zone, that kind of certainly puts limitations on your availability, as well as the resources that Amazon provides for you. So in order to get around that, you could use GSLB to deploy Netscalers in different availability zones. The downside is each one, the Netscalers themselves in the GSLB group must be authoritative for the DNS of the Netscaler access gateway. So that could be a pain. There's also no replication. You have to manually make changes to both instances if you need to do so. I am looking at AWS ELB, Elastic Load Balancer, to control traffic between the two Netscalers deployed in different availability zones. In this model, we would use the AWS's native ELB feature to do health checks and to control traffic between two different independent Netscalers. Again, in this case, there's no replication also, and any changes you make on one, you need to manually make on the other as it is relevant. There's a limitation with the ELB in that it will only load balance to instances on their default network adapter. So if you have more than one network adapter, you can't select. It's always stuck on the default. So I need to find a way to change the default network adapter to be the traffic processing or user-facing access gateway adapter, and then make the NSIP something else after post-deployment for this to work. It's probably doable, but that's just another headache to solve. But anyway, these two possibilities are that I can see that will allow you to do Netscaler HA across different AWS availability zones, and therefore enhance the availability of the option when you're choosing AWS as the platform to deliver Citrix. So this concludes this training video. I hope you find it useful. Again, this is just one way that I found that you can get this to work, Netscaler HA in AWS. There might be other options, and I encourage all of you to explore and make good use of and share the information that you have discovered with the community, and then we can all learn from one another. So I hope this was instructive, and hopefully I will see you in the future.